In this video, I'm going to be explaining the difference between conformations and isomers. These are two terms that you hear a lot in organic chemistry. Let's look at these two cats at the top. We have a cat standing versus a cat stretching. This is some normal movement that a cat can do. These are both cats. The relationship between these two cats is that they are conformations. Now, let's look at the cat on the top versus whatever this is down here. This is not a cat. Its tail and one of its front legs have traded places. This has all the same body parts as a cat, but a cat cannot just move and turn into this. The cat would have to be disassembled and reassembled differently. The relationship between these two is that they are isomers. Now, I'm going to be repeating this same explanation, but talking about molecules. I'm going to be talking about molecules with a molecular formula of C4H10. This is a molecule called butane, molecular formula C4H10. We have 4 black carbons in a chain, a total of 10 yellow hydrogens. Notice that right now, the carbons are in a zigzag shape. However, single bonds can rotate. So I can rotate some single bonds and end up with a different conformation. 4 black carbons are no longer in a zigzag shape, they're now more of a C shape. This is still butane, but it is a different conformation of butane. So conformations, the difference is rotation of single bonds. However, if I wanted to take this molecule of butane and turn it into something called 2-methylpropane, I would have to disassemble this molecular model and reassemble it differently. 2-methylpropane has the same molecular formula, C4H10, but I'm going to remove a CH3 group from the end and trade places with one of the hydrogens on what is now the middle carbon. This is now 2-methylpropane. Longest continuous chain of carbons, only has 3 carbons, 1, 2, 3. This carbon number 2 has a methyl group. This is 2-methylpropane. This is not butane. This is an isomer of butane. It has all the same parts, but in order to convert butane into this, we had to disassemble it and reassemble it differently. This is a molecule called cis-2-butene. Notice we still have 4 carbons in a chain, but between carbons 2 and 3 we now have a double bond. We also lost 2 hydrogens, so this now has a molecular formula of C4H8. What I want to point out is that multiple bonds, double bonds and triple bonds, cannot freely rotate. I can rotate this a little bit, but it snaps back to its original position. So right now, these 2 CH3 groups are both on the same side of this double bond. That is why this is named cis-2-butene. If I wanted to convert this into trans-2-butene, I would actually need to take it apart and reassemble it differently. So here you see we still have the double bond between carbons 2 and 3, but the 2 CH3 groups are on opposite sides of that double bond. These are not conformations of each other, these are isomers. So in ring structures, we can also not fully rotate bonds. So here we have 6 black carbons in a ring. If I pick one bond and I try to continuously rotate it, there's a limit to how much I can rotate it. That means ring structures are also going to limit rotation, even if they're single bonds. So you saw 2 different conformations of butane. You saw one in which the 4 carbons are a zigzag shape, and you saw a conformation in which they were more of a C shape. But the difference is free rotation about a single bond. This bond rotated. Importantly, conformations always have the same name. These are both named butane. When I was showing you the isomer of butane, it was not free rotation about a single bond. I had to disassemble the molecular model and put it together differently. You saw 3 carbons in the longest chain. Carbon number 2 had a methyl group, a CH3 group. These are isomers. These are isomers. Isomers have different names. This is 2-methyl-propane. So the difference between conformations is free rotation about a single bond. So if you had a double bond or a triple bond, it cannot freely rotate. That is why when we were talking about the 2 different versions of 2-butene, they were isomers of each other. And they also had different names. This was trans-2-butene. This was cis-2-butene. You also saw that in a ring structure, the single bonds could not freely rotate. So I was showing you a structure in which there were 6 carbons in a ring. That was hindering the free rotation. So in a ring structure, you would also have to pay attention to whether 2 functional groups were on different sides or the same side as the ring. Thanks for watching Chemistry in a Nutshell. If you feel that I've earned it, please like this video and subscribe to my channel.